Solving non-homogeneous higher order equations where the g of x here is linear is unique as well, together with the similar situations previously mentioned in our channel. Previously, we had a situation where g of x is constant. This time, g of x here is linear. Nevertheless, the solution for this given equation is structured in this manner. Y is equal to y sub c plus y sub p. Take note that we're using y because that's the variable indicated here. Now, y sub c is called as the complementary solution of this equation if our g of x here is just equal to 0. We had similar situations solving like that. It also tried to come up with 4 different situations, hence 4 different general solutions pertaining on the roots of the auxiliary equation. We're going to do it later, but that's for y sub c. The difference between that mentioned methods in this time is because, as mentioned, our g of x here, this is our g of x, is not 0, and this time it's linear. We have here y sub p, which tells us about the particular solution of the equation determined by solving the coefficients of this trial form. Given here is a table for all trial particular solution, and the second item pertains to linear equations or linear expressions. We're going to use that form for y sub p, and that is actually ax plus b. We'll be using this form later, even if our g of x here is just ax in nature, because that is the nature of the particular solution for this given equation. So we'll have that yp later. Let's start with solving y sub c. As mentioned, y sub c is the complementary equation if our g of x is 0. So we're going to use the same methods we did last time. So we will have here an equation with differential operator d expressing this given equation where it's equal to 0. So we will have here d squared minus 4, and then you have here y equal to 0, which will be translated to this auxiliary equation f of m equal to 0. In short, we will have here m squared minus 4 is equal to 0. So we're going to solve the root of this auxiliary equation and determine whether the roots are real or imaginary, and if there are repetitions. We know that m squared minus 4 is a perfect square. It's a difference of 2 squares. It's a binomial that can be expressed with these 2 factors, m plus 2 and m minus 2. Hence, our first root is equal to, this is our first root, equal to negative 2. And our second root is equal to 2. Now, we have 2 real roots and they are different. Hence, we'll be using the general solution for situations for auxiliary equation having distinct real roots, and it's structured in this manner. You have c sub 1 e to the power of m sub 1x plus c sub 2 e to the power of m sub 2x. Now, the m sub 1 and m sub 2 already explained here, and we just simply let c sub 1 and c sub 2 as it is. Hence, our y sub c is equal to c sub 1 e to the power of your first root minus 2x plus c sub 2 e to the power of your second root 2x. Now, you can interchange m sub 1 and m sub 2. It's still okay. Nevertheless, this is our y sub c for our general solution. Now, let's proceed to our y sub p. Our y sub p, as indicated earlier by the table of particular solutions, is expressed in this manner. Take note that we are going to express our solutions substituting y sub p and all of its derivative matching the highest degree. The highest degree here is second. So, with this, its first order derivative of y sub p, taking into consideration a and b are constants, you'll have here a, because b, or the first order derivative of b, is just 0. This would mean that the second order derivative of p is just equal to 0. Now that we have all of this, we are going to substitute that as we solve for y sub p, all the given equation. Our equation is actually y double prime minus 4y equal to minus 4x. So let's substitute For double prime, you have y double prime of b, 0, minus 4. Your y would be this y sub b here. That's 4 times ax plus b is equal to minus 4x. So, you will have here minus 4 ax minus 4b is equal to minus 4x. We would like to solve a and b coefficients because we are solving for y sub b, and y sub b is in this form. To solve for this, take note that our right-hand side contains only one term, and it's a term with x component. Hence, this should be equal to the other term with x on the left-hand side. So we'll have here 4, negative 4ax is equal to minus 4x. What happens then to our minus 4b? Since our left-hand side doesn't have any constant, we can simply say that minus 4b is equal to 0. So let's solve a and b this time. We can divide both sides with minus 4x here as well. So you will get a equal to simply 1. That's the value for our a. Now for b, of course, since it's equal to 0, b is also equal to 0. With both of this already identified, and our y sub b earlier, as mentioned in the table, is ax plus b. Ax plus b. So your y sub b is a, that's 1, times x plus 0. Y sub b is just equal to x. This is the y sub b that we need to add to this y sub c for our general solution here. So copying that, okay, hopefully I can memorize the result here, okay. So your y is y sub c plus y sub b. So y is equal to c sub 1 e to the power of minus 2x plus c sub 2 e to the power of 2x. Let me check if it's correct. Minus 2x and plus 2x. Yes. Then your y sub p, which is just equal to x. This is now the solution for your non-homogeneous differential equation expressed already earlier. Take note of the process. We have separated y sub c, which corresponds to the complementary solution, similar to the process of solving homogeneous equations, and the presence of y sub b indicated by the table earlier, and giving these values that will be substituted here for further computation of the coefficients a and b. Thank you very much for watching.